Okay, today we're going to be looking at 3.8. So on 3.8, our focus today is to identify roots using graphs and the discriminant. So roots is another word for like the solutions or your x-intercepts of the graph. So when we say, hey, draw a graph that has two real solutions or roots, we're saying we want it to have two x-intercepts, right? So you could have a graph like this, right? It could even be a parabola that opens down, right? As long as it crosses twice, then it has two solutions, right? So there's lots of different options. Those are definitely not the only two, but notice it's going to be that U shape that crosses over the x-axis twice. And we want it to have one real solution or root. It means that the vertex is going to sit on that x-axis, so it's only going to touch it once. Or similarly, you could have something that opens down, right? So it could be something like this as well, right? And those could be shifted right or left, could be anywhere along the graph. Last but not least, if we want something that has no real solutions or roots, it means that the parabola sits entirely either above or entirely below the x-axis, such that it never crosses. Okay, now we've learned the quadratic formula in class, right? The number of roots under the square root, the b squared minus 4ac, right, from the quadratic formula, is called the discriminant. And is used to determine the number underneath the square roots, the b squared minus 4ac, is called the discriminant, and that is used to determine the number and type of solutions. So these are all synonyms. Sometimes I use the abbreviation ROCS for roots, zeros, x-intercepts, and solutions. So we got our solutions, our roots, our zeros, or our x-intercepts. Doesn't matter which of those vocab words we use, we're talking about the same things. So in particular, if we want to think about the value of the discriminant, so what we're taking the square root of, if it is positive, so if b squared minus 4ac is greater than 0, so it's positive, then it's going to have two solutions. If it's strictly equal to 0, it means that it has just one solution. That's because you'll have like that negative b plus or minus the square root of 0 all over 2a. So notice how the plus or minus just disappears. So therefore, that's kind of where you're getting your only one solution, because we don't get the 2 from the plus and minus. If it has no solutions, this is something we're going to learn about. We're also going to call these, I should say, no real solutions, sorry. So it means that they have imaginary solutions. And we're going to learn more about imaginary numbers this unit. It means that your discriminant is less than 0. So we're going to start taking the square root of things that have negative numbers. And those are going to be imaginary. Okay, so now let's talk about, there's two different types of real solutions, two real solutions. If you get things like a perfect square, so something like 4 or 9 or 16 or 25, right? Things that will take the square root nicely. We call those numbers rational solutions because they'll come out in a ratio, right? If you get something that's not a perfect square, so 2, 3, right, 5, 7, even something like 20, etc. So something where the square root comes out to be a decimal, right? It doesn't matter if we can simplify it or not. We're going to call those irrational. So let's go ahead and determine, given the determinant, determine the number of solutions and what type. So for example, if your discriminant is 0, we said that there's going to be one real solution. Technically, that is rational if you're wanting to know, because it will be a ratio. If your discriminant is 16, that means it's positive, so it means that there are two real solutions. And those solutions, if you think about taking the square root of 16, that comes out to just be 4, so it's a nice number, so we call them rational solutions. I'm going to just rewrite that as two real rational solutions, because I think that's how your homework phrases it. Okay, 9 here. So Here we have 0, when you take a negative 9, we have 0 real solutions, which means that the 2 solutions are imaginary. So there's 2 imaginary solutions. So we haven't quite learned about it, but basically whenever you take the square root of a negative number, we're going to get something imaginary. Stay tuned to next time, that's what we're going to learn about. Last but not least, it is 42. Now notice the square root of 42, if you type it in your calculator, you get a decimal. So even though you can simplify it, like we can break it down to 6 times 7 and 2 times 3, it doesn't even matter if you can pull a number or not out. Since this is not a nice number, we call them, while they're still 2 real, we call them irrational. So things that are left with the square root are irrational numbers. I mean, the decimals go on forever, they don't repeat, we can't write it as a ratio or fraction. Okay, let's actually put it into practice. So we want to find the discriminant, and then from that indicate the number of solutions and sketch the graph of the quadratic. So remember, before we even find the discriminant, which is your b squared minus 4ac, we want to have this in order. So we're going to have negative 6x squared minus 7x minus 3 equals 0, right? Because we need to be able to find a, b, and c easy. And when you have it in that order, you will be able to recognize what a, b, and c is. But remember, if you're not careful, you may rewrite, you may call negative 3b when in reality it is c. Okay, I should say from ax squared plus bx plus c equals 0. So make sure it's in standard format. Okay, so our discriminant, okay, that's too long to write. I'm just going to say like the b squared minus 4ac. Actually, I'm going to use the word d for discriminant. So the discriminant equals negative 7 squared, remember to put those parentheses around the negative, times negative minus 4 times a times c. So here we get 49, and then we're going to go ahead and multiply these together. Negative 4 times negative 6 times negative 3, we have minus 72. So 49 minus 72, we get negative 23 as the discriminant, which then implies, since this is negative, there are 0 real solutions, right? Meaning, hey, it doesn't cross the x-intercept, which also means there's 2 imaginary. Okay, what I said here is just double check it with a graph. So whether you've got your graphing calculator nearby or you want to pull out decimals, let's type it in, negative 6x squared. Oops, that didn't work. And you can either type in the original, like minus 3 minus 7x, or you can type in the way we rearranged it. Either way, you should get the same thing. But notice here your graph, it never crosses the x-axis, which makes sense because we said, hey, if it never crosses the x-axis, that's a good sign because it means that there's no solutions, right? No real ones at least. So that kind of checks what we've done. Okay, let's look at the next one. The next one here, we've got to go ahead and put it in standard form, set it equal to 0. So I'm going to add 8x squared to both sides. So I get 5x squared plus 10x plus 5 equals 0. A is 5, B is 10, C is 5. So our discriminant equals 10 squared minus 4 times 5 times 5. So we get 100 minus 100. So we end up with 0. If our discriminant is 0, that means that there is just 1 real solution. Which means as we look at our graph, it should look as if it crosses the x-axis just once. So let's go ahead, let's graph it, just double check. This time we will have to type in the equation we got because the first one is not set equal to 0, so we can't just put in a y there. Notice as we take a look at it, right, it does just cross the x-axis once. It sits on there. Okay, so that 1 real solution looks good because it just sits on there once. It only touches it once. Okay, next we've got not quite in standard form, so let's go ahead, set it equal to 0. I'm going to subtract 8 from both sides. And I'm going to rearrange it. So it's 8x squared plus 9x minus 8 equals 0. A is 8, B is 9, C is negative 8. So D equals 9 squared minus 4 times 8 times negative 8. 9 squared is 81. 4 times 8 times a negative 8. And if I do a negative 4, I get positive 256. So 81 plus 256 is 337. And that's one of those, if you're not sure if it takes this perfect square or not, just take the square root of that, and you'll notice you get a decimal. So that means that while it is positive, so it means there's two real solutions, they are irrational. So they're not going to come out nicely. Okay, let's see what the graph looks like. So now we've got 8x squared plus 9x minus 8. And you'll notice it does cross twice, but you'll notice there are at decimals. So it looks something like, oh, I just forgot what it looked like real quick. Okay, we go back, something like this. Oops, that was a little bit funky. Oh, there we go. So yes, it did have two x-intercepts, just like you'd expect. Okay, two more here. So this time set it equal to 0. I'm actually going to add the 9x squared to both sides. So you'd have 0 equals 9x squared minus 8x plus 8. So A is 9, B is a negative 8, and C is 8. So our discriminant equals negative 8 squared minus 4 times 9 times 8. So we get 64 minus 288, sorry. So we get negative 224. So once again, because it's negative, that means that there's no real solutions. So 0 real solutions. However, if there's no real ones, it does mean that there are 2 imaginary in this case. So it means as we look at our graph, it doesn't cross the x-axis. So let's make sure that's true. It's always good practice to get some practice graphing. Sure enough, doesn't cross the x-axis, it's well above it. So in this case, it looks like this. Okay, one last one. So we've got, almost in standard form, not quite. We're going to subtract the 5x from both sides. So we get x squared minus 5x plus 2 equals 0. A equals 1. Remember, A, like the value will only be 0 if there's none of it there. So like it won't even be in the equation. Okay, our discriminant equals negative 5 squared minus 4 times 1 times 2. So we've got 25 minus 8. 25 minus 8 is 17. Once again, that means since it's positive, there's 2 real solutions, but the square root of 17 doesn't come out to a nice number. It's not a perfect square. So there's 2 real irrational solutions. And as I look at my graph, I'd have x squared minus 5x plus 2. Sure enough, it crosses the x-axis twice there. So we do know that we did it correctly. So our graph looks something like this again. Cross the x-axis twice. Oh, I drew it a little bit wrong. Sorry, let's go back. It was both over here, my bad. Okay. So something that kind of goes along with this is just what we call the fundamental theorem of algebra, which says every polynomial function, so that means like x to some power, of degree at least 1 has exactly n zeros. And that can include multiplicities or complex roots. So complex roots is another way to say like, hey, ones that have imaginary numbers as part of it. Okay, So as we think about this, we're saying, okay, in other words, the leading term of a polynomial is x to the 8th. So we call that an 8th degree polynomial. Then it means that there's 8 roots. So it potentially could cross the x-axis 8 times. Or if it doesn't, that's maybe there's some imaginary ones or some that are repeated. So an equation like 2x squared minus 4x minus x minus 1, you want to look for the highest degree polynomial. So in this case, we got to the 4th power. So that means it's degree 4, and that means that there's going to be 4 solutions. So how many solutions do each of the following have? Y equals 3 minus x to the 9th. X to the 9th would be the highest degree. So there's going to be 9 solutions. If you got something like f of x equals 4x squared minus 7x plus x, 7x to the 6th is the highest degree, so you just got to look at that exponent. It's the 6th degree. So there's possible of 6 solutions. In later math classes, you'll study polynomial functions that contain higher order degrees, such as x to the 3rd or x to the 5th. Do you believe this theorem holds true for quadratic functions? So meaning, do you believe there's at least 2 solutions for every quadratic? So in one case, we had 2 real. We had 2 imaginary, right, when there was 0 real. The 1 real, though, that's a little bit tricky there. In that case, we actually call it a repeated. So it means like it happens twice, which you'll learn about next year, too. So do all functions y equals ax squared plus bx plus c always have 2 roots? Yes. And we talked about, hey, there's either 2 real, there's 2 imaginary, or there's 1 repeated real. And that will be enough for now. Good luck with your assignment.